plane took 6 hours to fly to its destination with the wind and 8 hours on the return trip against the wind. If the distance of the trip is 3,600 miles each direction, find the speed of the plane. Okay, we're finding the speed of the plane and the wind speed. This is the pattern where we write distance equals rate times time, and we set up two equations. For the first equation, we've got the distance is 3,600. The speed going to the destination is 6 hours with the wind. You're going to get a boost, so plus the wind, and that's going to be for 6 hours. The second trip, the return trip, is the same distance, 3,600 miles. It's against the wind, so we're going to have R minus W for 8 hours. And just as I showed you in the video that taught you this stuff, we can always divide through by that time. So we're going to divide through by 6 for the first equation and 8 for the second. We can't always do that, but in ALEKS it's always going to turn out that way. So 3,600 divided by 6 gives us 600 is equal to R plus W. And the 3,600 divided by 8 gives us 450 is equal to the R minus W. Adding down, those W's cancel. We get 1,050 is equal to 2R. Therefore, dividing through by 2 gives us 525 miles per hour as the speed of the plane. We're then going to substitute back into one of the original equations. I choose the top one there. 525 for R plus what makes 600? It turns out the wind is 75 miles per hour on this problem. Now we turn the page, if I can get a hold of it. Okay. Moving on, we have a system of equations again. The second equation has a y equals, so that's just kind of crying out, use substitution. So the top equation becomes 3x plus 2 times input equals 8. And we're inputting the second equation, negative 3 halves x plus 4. Let's do our distribution here. We have 3x plus, the 2's are going to cancel, just leaving really a negative 3x, so goodbye to that plus, making a minus 3x, plus 8, that's my 2 times 4, equals 8. We notice that the x terms are going to cancel. We're going to have 8 equals 8, and whenever we get a true statement like that, we say that there is an infinite number of solutions to this problem. Not the same as all real numbers. Word problem. Pat bought a combination of 42-cent stamps and 50-cent stamps. Okay, it sounds like a mixture problem. We have two different prices that we're mixing together. So I know we don't mix them in bowls, but here we go anyways. We've got 42-cent stamps and we've got 50-cent stamps we're mixing together. She spent a total of $22.60. That is a total on 50 stamps. So 50 is the total number of items, and we want to know how many of each type. So X and Y. I'm going to multiply through by 100, moving those decimals over 2 places. My first equation is going to be 42x, top times bottom, plus 50y, top times bottom, equals 2,260. Stop there because it's a total. Don't go top times bottom. The second equation, reading across the bottom here, will just be x plus y equals the 50. I'm going to choose to go with the 50 just because it's a nice rounder number. I'm going to keep the top equation as is, and the second equation I'm going to multiply through by negative 50. So that first equation gets rewritten here, 42x plus 50y equals 2,260. And the second equation, multiplying through by negative 50, gives us negative 50x minus 50y equals negative 2,500. We designed this problem so the y's would cancel each other out. Adding down in the x column, we get negative 8x. And over on the right, there's more negativeness, and these are 240 apart, so negative 240. When we divide through by negative 8, we find out that x is equal to 30, and x is the 42-cent stamps. And we know that there are 50 stamps altogether, so there's 30 of one type, and you guessed it, 20 of the other type. These are the 50-cent stamps. So we do have a total of 50 stamps, and if we were to do the total, we'd find out it cost $22.60.